Have you ever wondered how your devices actually connect, talk, and stay protected on a network? From basic building blocks like hubs and switches to advanced tools like firewalls and intrusion detection systems, each piece of network hardware plays a critical role. In this video, we're breaking down core network devices you'll run into in IT, networking, and cybersecurity, what they do, how they work, and where they fit in. Let's get into it. Let's start with hubs. Before switches became the standard, which we'll cover in just a moment, many networks used hubs. A hub is a basic device that operates at layer 1 of the OSI model. It takes incoming electrical signals and broadcasts them out to all connected devices, whether they're the intended recipient or not. That means every device on the network sees all the traffic, which creates unnecessary congestion and potential security risks. That's where switches come in. A switch is like a hub, but much smarter. It's a network device with multiple Ethernet ports that allows you to connect devices like computers, printers, or servers to the same local area network, or LAN. Switches operate at layer 2 of the OSI model, which means they forward data called frames based on MAC addresses. MAC addresses are physical addresses that are burned into the device's network interface card, or NIC, and are unique to every device. When a device sends data, the switch reads the destination MAC address and sends the data only to the correct port associated with that MAC address, and not to every device on the network like a hub would. This makes communication faster, more efficient, and more secure. And if you're not familiar with the OSI model or want a refresher, I've got a video that breaks it down, and I'll leave a link to that in the description of the video if you'd like to check that out. Next, we have routers. This is a device that allows us to send traffic to devices on other networks, including the internet. It does this by creating and forwarding packets. Much like if we are addressing a letter to a friend, we need to provide a destination. In networking, this is an IP address. Routers examine the destination IP address and use that information to determine the best path for the packet to take. This process is known as routing, and it's why routers operate on layer 3 of the OSI model. Now that we've covered how traffic gets between networks, let's talk about how devices connect using wireless access points. A wireless access point, or wireless AP, is a networking device that allows wireless devices like laptops, smartphones, and tablets to connect to a wired network. It works by broadcasting a Wi-Fi signal that nearby devices can join. And behind the scenes, the access point is connected to a wired switch or router, bridging the wireless traffic into the local network so devices can communicate with others or access the internet. Access points operate primarily at layer 2 of the OSI model, since they deal with MAC addresses and frame delivery, but they're also responsible for managing wireless specific functions like authentication, encryption, and channel selection to reduce interference. In smaller setups like home networks, wireless functionality is often built into something called a SOHO router, or small office home office, which combines the functions of a switch, router, and wireless access point into a single device and works great for residences or small offices. However, for large business environments, standalone access points mounted to the ceiling are very common, and you'll likely see multiple of them working together to provide coverage across large areas like office buildings. Let's talk about firewalls. A firewall is a network security device that monitors traffic flowing into or out of a network and decides whether to allow or block the traffic based on a set of rules. These rules are defined in something called an access control list, or ACL. Traditional firewalls inspect certain attributes of the traffic, like source and destination IP addresses, port numbers, and protocol types to make their decisions. These type of firewalls are often referred to as packet filtering firewalls, and they usually operate at layer 4 of the OSI model, which is the transport layer. Firewalls play a key role in creating boundaries between trusted and untrusted networks, like between your internal network and the internet, helping prevent unauthorized access and potential attacks. A modem, short for modulator demodulator, is a device that allows your local network to communicate with your internet service provider, or ISP. It works by translating digital data from your network into analog signals that travel over mediums like cable lines, phone lines, or fiber optics, and then converting incoming analog signals back into digital data that your devices can understand. Modems operate at layer 1 of the OSI model since they deal strictly with electrical or optical signal transmission. You'll often see a modem as the first device connected to the wall jack provided by your internet service provider. And you'll typically connect a modem to the WAN port of a router, linking your local network to the wider internet. In many home networks, the modem may be combined with other devices like a router or firewall into a single unit, especially hardware provided by your internet service provider. But in larger or more customized setups, The modem is a standalone device that simply hands off connectivity to a more capable router or firewall. A load balancer is a networking device or software that distributes incoming network traffic across multiple servers. The goal is to prevent any single server from getting overwhelmed, which improves performance, uptime, and reliability. Think of it like a traffic cop directing cars to different open lanes. Instead of sending every request to one server, the load balancer spreads requests across multiple backend systems based on availability, performance, or health checks. Load balancers typically operate at layer 4, the transport layer, or layer 7, the application layer of the OSI model. Layer 4 load balancers make decisions based on IP addresses and TCP and UDP ports. Layer 7 load balancers go deeper, making decisions based on application level data like URLs, cookies, or specific HTTP headers. You'll often find load balancers in web hosting environments, cloud infrastructure, or any system that needs high availability. Finally, we have intrusion detection systems and intrusion prevention systems. These tools are designed to monitor and respond to suspicious or malicious activity on a network. An intrusion detection system, or IDS, acts like a security camera. It watches network traffic, comparing it to known attack patterns or anomalies, and raises alerts when something looks wrong. An intrusion prevention system, or IPS, goes further. Not only does it detect malicious traffic, but it can block or drop it automatically to prevent damage. These are typically in line with the traffic, meaning all traffic flows through them before being allowed into or out of the network. And these systems generally operate at layer 7 of the OSI model, since they inspect the contents of network traffic to detect threats like malware, port scans, or brute force attacks. However, it is worth noting that these systems can sometimes incorrectly flag legitimate traffic as malicious, a false positive, which is why tuning and regular rule management is important. You might see intrusion detection system and intrusion prevention systems as standalone appliances, but they're commonly part of next generation firewalls that bundle multiple security functions into one device, and we'll cover that in a later video. We just covered some of the most common networking devices you'll encounter, from the simple hub all the way to the more advanced tools like intrusion detection, intrusion prevention systems. Hubs broadcast network traffic to every device connected to it. Switches forward data intelligently using MAC addresses. Routers connect different networks using IP addresses. Wireless access points bring wireless devices into a wired network. Firewalls control traffic with rules to protect your network. Modems connect you to the internet by translating signals. Load balancers distribute traffic to keep services fast and reliable. And intrusion detection and intrusion prevention systems monitor traffic to detect and sometimes stop threats in real time. Understanding what these devices do and how they interact give you a strong foundation for both networking fundamentals and cybersecurity principles. Whether you're studying for a certification, breaking into the field, or just brushing up, this knowledge is essential. The more you understand the tools, the better you'll be at securing the systems that use them. If you enjoyed this video, please consider checking out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.